All right, let's dive in. Today, we're going to talk about something fascinating, how AI actually developed a memory. We're going to break down the whole evolution, from these really simple loops to the complex, almost brain-like structures that are powering the tech we use every single day.
You know that feeling when your phone just knows what you're going to type next, or how a voice assistant can actually follow what you're saying in a conversation? Well, the secret sauce is a special kind of AI. It doesn't just see the world in snapshots. It understands the flow of time and context. In other words, it has a memory.
So to really get why memory is such a huge game changer for AI, we first need to look at what the older, more traditional models couldn't do. Let's start there. Think about it like this. Traditional networks were fantastic for tasks like identifying a cat in a single photograph. Perfect. Each picture is its own separate event. But that's not how our world works, right? Our world is more like a movie. Language, speech, even stock market data. It's all sequential. The order of words can completely change what a sentence means. These old models were stateless. They had zero memory, and that was a massive problem. So how did researchers tackle this whole memory problem?
Well, the first major breakthrough was a real pioneer for sequential data, the Recurrent Neural Network, or RNN. You could say this was AI's first real shot at creating a memory of its own.
This idea actually came about way back in the 1980s, and the concept was, well, it was both revolutionary and incredibly elegant. It introduced a simple feedback loop, which allowed information to stick around. It keeps this internal memory, what we call a hidden state, that lets it remember what it saw in the previous steps of a sequence.
Okay, I know what you're thinking, an equation. But don't let it scare you off, because the idea here is actually super simple. All this is saying is that the new memory, HT, is just a mix of the brand new information, XT, and the old memory it had from the last step, HT-1. It's just the math for combining what's new with what's old. So here's how that process really works in practice. At every single step, the network takes a new piece of information, like the next word in a sentence, and it mixes it with its memory of all the words that came before. That combination creates a new, updated memory. So the network's understanding at any given moment is literally a product of everything it's seen up to that point. But, and there's always a but, right? This beautifully simple memory loop had a critical, almost fatal flaw. As the sequences got longer and longer, the RNNs started to get, well, forgetful. This quote just nails the problem perfectly. As more and more new information got fed into that loop, the influence of the stuff from the beginning would just fade away. This is a famous problem in the field called the vanishing gradient. The network essentially lost the plot. It couldn't remember the long-term context. Now, this problem could actually show up in two different ways. With the vanishing gradient, like we said, the network pretty much forgets the past. But it could also go the other way with something called an exploding gradient, where it would totally overreact to new information. That made the whole learning process chaotic and super unstable. For any job that needed long-term memory, the simple RNN just wasn't cutting it. So this whole memory problem, it really demanded a much more sophisticated solution. And this led to a truly brilliant innovation, one designed to give AI a more robust, selective, and long-term memory. So let's meet the Long Short-Term Memory Network, or LSTM. The name, Long Short-Term Memory, it really says it all. It was built from the ground up to handle both short-term details and, crucially, those long-term dependencies in the data. Its secret weapon is this clever system of gates that work like filters, intelligently controlling how information flows through the network. The best way to think of it is like a highly efficient brain. It's got a main memory cell for long-term storage, but then it has these three gatekeepers. The forget gate does some spring cleaning. It throws out old, irrelevant information. The input gate acts like a bouncer, deciding what new info is important enough to get saved. And then finally, the output gate decides which part of that memory is actually relevant to produce a result right now. So when you put them head to head, the difference is crystal clear. A simple RNN's memory fades because of that whole vanishing gradient issue. But an LSTM, with its sophisticated gated architecture, can protect and carry important information across incredibly long sequences. That's what makes it so much more powerful for complex stuff. Okay, so we've seen how RNNs and LSTMs handle sequences over time. But what about just understanding the data itself? To complete our toolkit, we need to briefly touch on a different kind of network that's a master at a totally different job, the autoencoder. Now, unlike RNNs or LSTMs,
An autoencoder isn't about memory over time. Its whole purpose is to learn the absolute essence of a piece of data. It takes an input, say an image, and squeezes it down to its most important features. We call this encoding, and then it tries to rebuild the original image from just that compressed version. This makes it a master of things like data compression or spotting when something is weird or out of place. So the real key takeaway here is this. Choosing the right AI model is all about understanding your data. If your data points are all independent, a standard network is fine. If you've got a short sequence, an RNN might do the trick, but for long, complex sequences where context is absolutely everything, the LSTM is your go-to. And if you just want to understand the core structure of your data itself, well, that's a job for an autoencoder. You know, this ability for AI to not just see something, but to remember and understand the context, that's what's driving everything from better text prediction to incredible scientific discoveries. And as this technology just keeps getting better, we're left with a pretty provocative thought to chew on. If AI can now remember and learn from the past, what is it going to predict about our future? So where's this from? It's all coming from the channel Learn with Praveen.